Welcome back to Section 8, Solving Equations with Logarithms. In order to solve a simple logarithmic equation, first rewrite the logarithmic statement as an exponential. Question 1. Solve the following for x. Part A. Log base 2 of x is equal to 7. So to solve this particular equation, we're going to write it as an exponential. So 7. And to do that, I'm going to raise both sides of the equation to the power of 2, like so. And because we've raised it, then the 2 log 2 cancel. And thus what we're left with is x equals 2 to the power of 7. So x in this case is equal to 2 to the power of 7. Going across to b, we've got log base 5. X minus 2 is equal to 3. Using the exact same technique as in part A, by raising both sides to the base of the logarithm that we're dealing with, we can rid ourselves of the logarithm in the equation. So raising both sides to the power of 5, like so, we get rid of our 5 log 5. And thus we're left with an equation. X minus 2 equals 5 to the power of 3. Solving for x, we find that x is therefore equal to 127. Going down, in part C, we've got log base x of 216 equals 3. Raising both sides to the base of the logarithm, which is x. We take the cube root of both sides of the equation, so we can write it as its radical notation, or if we wanted to, we could write it in its index notation. Solving with our calculators, we find that x is equal to, or the cube root of 216 is equal to 6. And remember, at this level of mathematics, we're only expecting one real solution because it's a cube root. If it was a square root, we'd expect 2, but because it's cubed, we only expect one real root. Going across to D, we've got log x, log x equals 4. And remember, because the base is not specified, it defaults to a base of 10. So, to solve this particular problem, we're going to raise both sides of the equation to the power of 10. Thus, the 10 log 10 cancel. We get 10 to the power of 4. Thus, x is equal to 10 to the power of 4. Going down to E and F, log x is approximately equal to negative 0.5. So solving this problem, recall that the base is not stated, so it's an implied 10. We raise both sides to 10. And we can write this in our radical notation. So it's going to be 10, or 1 over the square root of 10, and that's going to equal approximately 0.316. So expressing this radical, or this surd here, to 3 decimal places, it is 0.316. Now going across to F, we've got log 5x equals 3 over 2. So remember, it's an implied log base 10. Thus, raising both sides to the 10, we get 5x equals 10 to the power of 3 over 2. Now writing it in our surd notation, we find that it is the square root of 10 cubed. And then dealing with this coefficient of 5 in front of the x, we find that our answer is the square root of 10 to the power of 3 all divided by 5. And remember, we don't need the square in front there because it's implied with a square root. Now, we can simplify this down a little bit further in that we can rewrite this surd here as 2 root 10. Or if we wanted to evaluate it, the answer will come out to be approximately, x will approximately equal 6.325.